It more than doubled what we needed. That was a moment where I was like, okay, there's something here. This is pretty amazing. You'll be able to immediately measure to the dollar in some cases how effective your efforts were.
What's up, everybody? How's it going? In this video, I am joined by a very special guest. His name is Ryan. He is an ex-Amazon machine learning infrastructure engineer, and we are going to be talking about what an ML engineer does on a day-to-day basis at a big tech company like Amazon. Now, for those of you who heard our recent announcement, you know that Ryan is the creator of ML Expert being Algo Expert's brand new machine learning interview prep offering. If you're interested in that, definitely go check it out at algoexpert.io/ML. And with that, Ryan, why don't you start us off by telling us a little bit about yourself, what you did at Amazon in a couple sentences, and then we'll dive into more details.
Hey everyone, I'm Ryan, and for about the last 5 years, I was at Amazon. I started out as a software development engineer, that'd be like your software engineer, and then I moved into a machine learning engineer role, and then I finally ended at a machine learning infrastructure engineering role. But for this video, I think we're going to take away the nuances between machine learning engineer and machine learning infrastructure engineer, and we'll kind of just talk about those as one.
Okay, awesome. And I think I'm going to add a caveat here for viewers by saying that machine learning is extremely complicated and vast. So there's a lot of stuff. Hopefully, Ryan and I will do a good job here of distilling it into something that's palatable. But do keep in mind that it is a really, really complicated and vast field. But so on that note, Ryan, why don't you tell us, in a nutshell, what it is that an ML engineer does at these big tech companies?
Yeah, so let's say that we wanted to build a Netflix clone or something, or let's say we were just building Netflix. We would need a lot of people to help us, and let's say that they built the website and together we built the website. And then all of a sudden we launched, and now users were using it, but the only way they could find their shows or movies was with a search function. Well, that could be tedious for users. If they just want to search for every single thing that they want to watch, they have to know what they want to watch. So let's say that we took it a step further and wanted to implement some sort of recommendation. So based on what users have previously watched, we could develop some way to show them shows or movies that they could be interested in. Here, that is exactly that differentiation between the software developer and the machine learning engineer. The machine learning engineer would be able to come in and help build that recommendation engine, while the software development engineers would mainly focus on all of the systems that surround that recommendation system.
I see. So here you're saying that the machine learning person would take in whatever the user has previously watched and maybe other forms of data, and then give them a recommendation. That would be the role of the ML engineer.
That's right. And they have to do things before they actually put that model into use for your system, because you have to make sure that it's going to work somewhat well, at least before you deploy it blindly, basically. So a big portion of their job is to find the right data, find the right models, make sure before they actually put it in production that it's going to work somewhat well at least, or they hope it will work well, and then obviously measure it once they have launched it, maybe with an experiment. And then finally, if the experiment goes well, they have to deploy it perhaps to different countries or maybe more users.
So I'm curious, because here what you're describing sounds to some extent very much like software engineering. It doesn't sound too daunting from a sort of math perspective or academic perspective, but I feel like a lot of people, myself included, think that machine learning is very theoretical and not that much like software engineering. What would you say to that?
Well, I think that you can make it what you want it to be. So as a software engineer, you're going to be importing libraries all the time. And more often than not, a machine learning engineer will just be importing libraries, but in this case, those libraries will perform machine learning. Now, obviously, it's not just as easy as importing a library. Like we talked about, you have to do things outside of just simply importing the library and serving those predictions to users. You need that data, and you need other things. You need to validate that these models may work to some capacity when they're launched into production. But generally, you're right. That's extremely similar to what a software development engineer would do.
Interesting, interesting. That makes it more approachable, I feel like, for a lot of people who might think that it's a different type of thing, that it's just like you have to be, a researcher, or you have to have a PhD to be an ML engineer. Because I guess, correct me if I'm wrong, like, do you need to have a PhD to be an ML engineer? Do you have a PhD?
I thought you did. I actually had that assumption when I went into Amazon. I had taken a couple of classes. I started out as like an electrical computer engineer. I didn't like that as much, so I really wanted to go to the software space. But the thing is I ended up taking several classes in machine learning, and at that point, the professors that I had, they were like, oh, if you get a PhD, you can be an ML researcher for these companies. And I interned over at Amazon, and I found that no, you don't. You need to obviously know about the topics, and at that point, you could take ML Expert to help you get there. But you don't have to actually be a PhD. I know several people, like I don't even have my master's, and I know people alongside me too that didn't have their master's that were also machine learning engineers.
That's awesome. I mean, first of all, thanks for the shameless ML Expert plug. Ryan is
I
clearly
just slid it right in.
clearly learning the game great here, but that's really awesome to know. I think that a lot of people will be happy to hear that, and maybe we'll make another video purely about that topic. But I guess going back to the role of an ML engineer, I really liked the example that you gave with Netflix and creating recommendations. One thing I'm curious about is the use of machine learning always dictated by the product that you're building? So, for example, here in the Netflix thing that you gave, it seems like the only way that you could create a recommendation system is with machine learning, right? You have to predict what the user likes, so you need to use machine learning. Is it sometimes the case that it is unclear that you need machine learning to solve a problem?
Yes, and I would actually kind of say that this recommendation engine is also somewhat unclear. You were saying that you need machine learning to solve this, and frankly, you don't really. So something that we could do extremely simple is, let's say that we have your watch history. So we know all the shows that you've watched, we know all the movies you've watched. We could just hire some people to come and manually label what category those shows were. Were they comedies, horror films, dramas, and then we could just count. You've watched 27 dramas and you've watched 2 comedies. Well, the first thing I'm going to recommend to you is a drama. And that's an extremely simple algorithm. Here we would call that a heuristic in the MLE, or the machine learning engineering world. And the reason why you would bring in machine learning is to help boost the performance or beat those heuristics.
I see. So does that mean that there are cases where you use machine learning and it just doesn't work? Like, it doesn't beat the heuristic?
That's absolutely true. You'd be surprised when applying machine learning to different spaces. It's not uncommon that the heuristic actually works quite well. And in that case, you have to make a decision. Okay, do we actually want to use machine learning here? Or should we just stick with the heuristic? Maybe we can improve the heuristic a little bit. Where heuristics really run into problems is scaling them out past a single situation. So let's say that we had a heuristic that we used for our Netflix clone in a country or with a customer segment, and we just had to rewrite all of these heuristics for all the different countries for them to work well. Well, that's just not going to scale as your product grows. So oftentimes it's easier to kind of let the heuristic maybe be better than the machine learning model up front, but just afford yourself all of that scalability.
I see. So you would decide to implement machine learning in anticipation of needing scalability.
That's definitely a case. That's not the only case. You can start with machine learning. I don't often recommend it because it's harder to understand your customers if you just throw a machine learning model at something. It's better to make a guess, like a hypothesis.
Okay.
If I do this, then something else will happen, and that's typically going to take the form of a heuristic.
I see. So I guess moving on a little bit, one thing that I'm curious about is, and we perhaps touched on this a little bit before when we talked about the PhDs and all that, would you say that your work as an ML engineer on a day-to-day basis is more practical than theoretical, or is there still a lot of theory and academic type of work?
So you can be more theoretical if you'd like, but generally what I've seen is we can just try certain things out, and that will either validate or invalidate some theory that we had.
So there's a lot of this sort of like experimenting with machine learning. It seems like in some sense it's not a perfect like science. It's much more iterative than a one-shot perfect thing.
It is, and it depends what level you look at it, right? So if you want to look at the machine learning in terms of its like most granular metrics, like maybe accuracy or recall, things like that, then it is more scientific at some level. If you want to look at things at a higher level, then it's much easier to just look at maybe click-through rates or some form of revenue and just try every single thing that you know to try and see what lands.
But so does that mean that these are things that you would do on the job? Like let's say you're using machine learning, I don't know, to make product predictions or Netflix show recommendations. Do you iterate on these models that you're deploying a lot? Like, do you change them all the time based on how users are reacting? Like, how does that work?
Yeah, that's exactly right. We change it for mainly two reasons. One, what if the customer base changes? So what if yesterday's machine learning model worked and today it doesn't? Then we need to update it. And meanwhile that's happening, we also want to improve every bit that we can the current model. So generally, the idea is to be in some form of constant experimentation. You don't have to do this, but this is what I commonly saw at Amazon.
I see. And I'm assuming that like a lot of that is based on the performance metrics of the model. So let's imagine that on Netflix you want users to be like happy and to watch a lot of shows. Do you track that? Like you track, how long they're watching the shows or how many products they're purchasing on Amazon to validate whether your models are working?
That's right. But in general, there's going to be more people with opinions on what exactly you should measure. So me as a machine learning engineer may be more concerned with the model metrics, and a product manager could be more interested in the metrics that you were talking about, maybe watch time, click-through rate, and maybe just total time on the platform itself.
I see. And so you have to kind of like, balance between all these different metrics that you could optimize for. So interesting. I'm curious, like for people who are watching who might not be in machine learning right now, but who might be interested in it, would you say that machine learning is like a lot more difficult than normal software engineering? And maybe also like, is it more fun? I'm assuming you're not going to say it's less fun, but I'm just curious to hear what you have to say about that.
Yeah, I'm biased. Like, I think it's more fun just because, I don't know, there's always something to do, and really your impact can be directly measured. And in some cases, that may not be what you want. Like, if something doesn't work, then people will say, oh, like that clearly didn't work. When I was a software engineer, I could spend maybe 6 to 12 months working with a team on a launch or maybe some feature, and we would have to maybe take another year to really determine how successful that thing was. So in terms of software engineering, that is, to me, harder, because you could be building something and may not know for a whole nother year if it actually worked. Now, for the machine learning engineer, you know pretty immediately, and in that case, it was better for me because I could move on if I found out that something just wasn't working.
So what do you mean? Like if you're running a machine learning model for, Netflix predictions and you see that just nobody ever clicks the recommendations, you kind of immediately, like in the first week that it's been deployed, you immediately get that feedback as an ML engineer?
Yeah, so typically it may not be a week, you may need a little bit longer, but it's typically under a month. And in that case, you learn about as much from something that doesn't work that does. So it's not like you say, oh, well, this just didn't work. Let's just throw it out and like start from scratch. Maybe if it hasn't worked like many times in a row. But
Right.
generally what you're going to do is, okay, everyone's clicking like the second or third one instead of the first one that we've recommended to them on Netflix. Well, you would take that information and go, and you'd start looking at the second and third one and try to figure out why your algorithm or your model isn't putting those second and third items first.
Right, I see. So you can always use feedback to then like try to further improve your machine learning. I'm curious, like,
That's the goal.
did you ever, I'm assuming that machine learning works, right? Otherwise, machine learning wouldn't be nearly as popular as it is. Otherwise, we wouldn't have created ML Expert. But were there times at Amazon, and of course, you don't have to reveal any confidential info, but were there times at Amazon where even you yourself were kind of like amazed at just how well a machine learning model worked and how much it kind of improved a business metric?
Yeah, I mean, I've been absolutely. That's actually why I stayed so long. I don't know if anyone has the intention to like set out just to stay somewhere for about 5 years, but it's kind of to the point where you're trying maybe a heuristic, so you're getting some return, some benefit, and then you try another model, and then that gets you a little bit more lift. I remember one time when we had a model and it was doing well, and one of my teammates said, "Hey, I think we should try something like this." And frankly, I was like, "I don't think that'll work. Like maybe we'll get like incremental benefits from this." But we tried it and it just totally smashed the other model. And at that point, I was like, "Okay, wow, like it more than doubled what we needed." And that was a moment where I was like, "Okay, there's something here. Like this is pretty amazing."
That's funny because like the way you describe it, it sounds very gamified by nature of just the way machine learning works. It sounds like there's a very gamified process to it where you're always trying to improve, continuous improvement.
That's right. And it'd be like anything that a software engineer would do. Like, oftentimes you want to improve latency or maybe improve the number of connections that your service can take, things like that. And those are also somewhat gamified, right? Like if you look at your metrics and you see that you've improved some latency metric, at that point you're very happy that you've done that. And the same case is true for machine learning engineers. But it's often the case where it's a different metric than latency. You're going to have click-through rates, revenue, maybe profit, or accuracy if you want to look at like the model level metrics.
Yeah, definitely. Damn, it's just really impressive to think how like you effectively like are making changes to these super important metrics with just like data and tweaking data and tweaking the way data is evaluated. Really cool. One final question that I have that I love to ask people always is, what about something that you don't like about being a machine learning engineer? What about something that was really tough about being a machine learning engineer?
Well, it's effectively what I talked about earlier, this ability to measure yourself like every step of the way and measure what your team is doing. At the same time, like let's say that we were just, software development engineers or software engineers, and we launched a product and, if people are using it, maybe 5 teams are using it or maybe 10 teams are using it. You never really know. It's hard to draw a clear line whether or not it was like successful or unsuccessful. It's easy to see when something's wildly successful, but beyond that, it's kind of nebulous. So you can kind of take some comfort in like, okay, so maybe if you only had 10 teams using your product that you've spent a year making, you can still kind of determine that, okay, it was a success because teams are using it.
Yeah.
But with the machine learning engineer, you'll be able to immediately measure to the dollar in some cases, how effective your efforts were. And so that is the double-edged sword. When it works, it really works, and when it doesn't, it can really kind of bring down your morale and say, okay, well, like now I really don't know what to try. I've tried several things over here. I've tried tweaking this and tweaking that, and it seems like nothing's working. That can get you down, but you have to remember that it's really just a numbers game, and you just have to keep trying, and eventually, given enough tries, you will be successful.
Right. Yeah, because I can imagine like you've spent months working on a model and you deploy it, and after a few weeks or months, you see that it's like revenue has just like remained unchanged or like almost like gone lower or something.
Yeah, well, that absolutely happens. It's horrible. And then you watch these experiments as they're taking place, and we talk about this in ML Expert that it's like it's not good to peek ahead during the experiment, but you can get like some indication on how your experiment is going. And so if you look and you're a week in, and let's say it's a 3-week experiment and it's already going down, you might have product people calling you up saying, hey, like we're taking a big loss over here. Like, is this worth continuing the experiment? And then you have to like reason with them and say, statistically, like it could still come back, but again, that is the nature of it.
Yeah, definitely. Listen, Ryan, that was awesome. I think you painted a really cool picture of what an ML engineer is. I really hope that all of you watching found this informative. Like I said at the beginning, this is a pretty complicated field and vast field. So hopefully, this still kind of gave you an idea of what ML engineers do. Are there any last words that you want to share, Ryan, about machine learning in general?
The only thing that I would say is that when I got into machine learning in school, I took a couple classes, but then I went to Amazon as a software development engineer. The transition from software development engineer to machine learning engineer is far less difficult than I thought it would be. And that is something that I should have actually done sooner. I should have just switched when I wanted to switch. But instead, I kind of let the common knowledge of, oh, you need a master's, or you need a PhD, or you need this and that, or you need this type of experiences. If I didn't listen to those so much, I probably would have done it earlier, and I probably would have had even more fun for longer at Amazon.
Well, there you have it. If you are currently a software engineer considering ML engineering, don't hesitate anymore. Just get after it.
Yeah, exactly.
On that note, I really hope that you enjoyed this video. If you did, don't hesitate to smash the like button and subscribe to the channel if you haven't already. If you're interested in machine learning and if you enjoyed hearing Ryan talk about it, go check out his YouTube channel. I will link it in the description and in the comments below. He's going to start posting some content about machine learning there. It's going to be really interesting. I would definitely recommend you do that. And otherwise, if you enjoy short form written content, follow me on LinkedIn and Twitter, Instagram if you like pictures, and I will see you in the next video.